Completing the square. We're about halfway through chapter 12 here, which deals with radicals and its connections to geometry. This is going to be yet another method for you guys to solve quadratic equations. We know that we can use the quadratic formula. We know that we can graph and look for x-intercepts. We also learned how to factor to solve quadratic equations. And here's going to be a fourth method for us. Here's the first thing we need to know. So if we've got an expression like x squared plus 20x, this question is asking us what term should we add to it so that the result is a perfect squared trinomial. All right, so this will make sense a little bit more after we get done and after we move on to example 2, but here's what we're looking to do. We've got x squared plus 20x, and we're being asked what should we add to it so that it's a perfect square trinomial. Well, if it's a perfect square trinomial, it should fit this form. And in this particular case, A would be x, and B is what we need to figure out so that we can find out B squared. Okay, so if it's a perfect square trinomial, it fits this form. We know that A is x, so we'll put that in both places. We're trying to figure out B. So right here is where we're looking in the middle. 2 times x times what equals 20x? Obviously, that's 10. The last term to make it a perfect square trinomial should be b squared. So 10 squared is 100. And that's our answer. Okay, the bottom line here is that if we have a lead coefficient of 1, to make a perfect square trinomial, we take b, half of b, and square it and add that to the expression. A little bit confusing. It'll make sense more once we use it. So let's do that now. Let's solve this quadratic equation by the method called completing the square. We could subtract 35 from both sides and then use the quadratic formula or try and factor it, but we're going to complete the square. And this is the form we want it in, where the x squared and x are on the left and everything else is on the right. So here's the way I'll set this up. X squared plus 2x plus blank equals 35 plus blank. So what are we going to add to both sides to make this a perfect square trinomial? Like I said, the lead coefficient's 1. So all I have to do is take half of b, half of 2 is 1, and then square that. 1 squared is 1. So I'm going to add 1 to both sides. And the reason I do that is because x squared plus 2x plus 1 can be rewritten as x plus 1 squared. Okay, x plus 1 squared should be a squared, 2ab, and b squared. So this and this are the same thing. But whatever you do to one side of the equation, you have to do to the other, golden rule. So we do that. All right. Now that's the completing the square. We completed the square. We can do anything we want to an equation as long as we do it to both sides. Continuing on with that theme, I'm going to take the square root of both sides. The square root of x plus 1 squared is x plus 1. And the square root of 36 is plus or minus 6. Subtract 1 from both sides. Negative 1 plus 6 is 5, and negative 1 minus 6 is negative 7. Those are the two solutions to this quadratic equation. Okay, I could have got those same solutions by graphing x squared plus 2x minus 35 and looking for where it hits the x-axis. I get those same solutions by factoring x squared plus 2x minus 35 equals 0. And I could get those same two solutions by doing the quadratic formula. This is just one more method. It's really, not that much work once you get the process down. You might like it. It's a lot less thinking than factoring also. All right, so let's solve this one by completing the square. All right, so first of all, we have to add 2 to both sides because we have to get the x squared and x term on the left by themselves. Then we have to determine, okay, what are we going to add to both sides to complete the square? Okay, where did I get 16? Let's slow down. Half of negative 8 is negative 4, and negative 4 squared is 16. So as long as the lead coefficient's 1, we can do that process. Negative 4 squared is 16. Add 16 to both sides. Then we can rewrite this as the square of a binomial. We can take the square root of both sides. Square root of x minus 4 squared is x minus 4. Square root of 18 is plus or minus the square root of 18. It's not a perfect square, so just leave it as a radical. Then we can add 4 to both sides. We'll get 4 plus or minus the square root of 18. One added step here to this is that the square root of 18 can be simplified. It's got a perfect square factor, 9. There's our answer, 4 plus or minus 3 times the square root of 2. If you did the quadratic formula, this is the same answer you would get. Okay, this expression is not factorable. There are no factors of -2 that add up to -8, so you can't use factoring. You could use the quadratic formula, and graphing isn't going to work for you too well because you're going to get an irrational answer. So some might say this is easier than the quadratic formula. I would agree when the lead coefficient is 1. Right here, you're going to find out why completing the square is not a good method when the lead coefficient is not 1. So let's do this. First of all, let's add 7 to both sides. Then I'm going to divide every term by 3 so that I can get a lead coefficient of 1. Now I have to determine, okay, what am I going to add to both sides? Half of 5/3 is 5/6. 5/6 squared is 25/36. This is getting messy, and I know you see it too. Let's rewrite 7/3 so we can get a common denominator here. Write this as the square of a binomial. X plus 5/6 squared equals 109 over 36. We'll take the square root of both sides. X plus 5/6 on the left, plus or minus the square root of 109 over 6 on the right. Subtract 5/6 from both sides. Not pretty, but we're done. I'll tell you, completing the square when the lead coefficient is not 1, and more specifically when your middle term is odd, not the best method. Really, I would use the quadratic formula, and that's what I'm going to go through right now. I'm going to prove to you guys that you get the same answer by doing it this way. Okay, so B would be 5, A would be 3, and C would be -7. Five squared is 25. Multiply, we get 84. 25 plus 84, guess what? 109. -5 plus or minus the square root of 109 over 6 is the solution. And hey, the green answer and the blue answer are the same thing. Just kind of rewritten. Instead of 2 fractions, it's written as 1 fraction. When lead coefficient's not 1, I would just use the quadratic formula. When the lead coefficient's 1 and the middle term is even, completing the square is pretty good, unless you can factor it pretty easily. Choose a method to solve the quadratic equation, and I'm going to definitely rationalize my choice. Okay, well, first thing, lead coefficient's 1. I want to look for factors of -10 that add up to -3. -5 and +2. This is very easily factored. So factor it, and then use the zero product property to get your solutions. I mean, definitely, if the lead coefficient is 1 and it's factorable, I'm going to use use factoring. Forget all that completing the square stuff. All right, well, what about here? Choose a method to solve the quadratic equation. Well, lead coefficient's not 1. It might be factorable, but I don't feel like doing the AC method. Let's see, what else? I could divide everything by 2 to make the lead coefficient 1, but then I'd have this -3/2 sitting over here. How about we just do the quadratic formula and be done with it? B is -6. A is 2. C is -3. Got 36 plus 24 inside the square root sign, which is 60. We can simplify that radical. It's divisible by a perfect square, 4. And then all three of our terms are divisible by 2. So we'll just simplify. Yeah, I'm not going to touch this one with completing the square. We're not done with it yet, though. All right. So why don't you try this one? Look back at example 1. What term added to x squared minus 12x results in a perfect square? My answer's coming up. All we got to do is take half of negative 12, or half of 12. You can kind of disregard the negative because you're going to square it anyway. That's it, 36. And the reason is that x squared minus 12x plus 36 is equal to a perfect square, x minus 6 squared. So a squared minus 2ab plus b squared. We're being told to solve this by completing the square. Oh, I would rather not, but since the directions told me to, I'm going to. The reason I say I'd rather not is because this middle term is odd. And give it a shot. Or if you just want to watch my solution, go ahead and let the video play. All right, here we go. What am I going to add to both sides? Well, half of 3 is 3 halves. 3 halves squared is 9/4. So we'll add 9/4 to both sides. Then I can write this as a perfect square. X minus 3 halves squared. And over here, I'm going to get a common denominator. And I'm going to add them up, 81/4. At least those are both perfect squares. That'll work out nice for us. Take the square root of both sides. Plus or minus, remember it's 2 square roots. Add 3 halves to both sides. And then simplify our answer here. We got 12 over 2, which is 6, and negative 6 over 2, which is negative 3. Yeah, it didn't turn out that bad, but you know, I might consider subtracting 18 from both sides and then trying to solve this by factoring, or because it obviously is factorable. We got a rational answer. Okay, let's solve this one by completing the square. Not going to be so bad, I don't think, this time. Add 11 to both sides. Half of 4 is 2, and 2 squared is 4, so let's add 4 to both sides. That is a perfect square trinomial, so let's write it as a perfect square. Let's take the square root of both sides. Remember, it's plus or minus the square root of 15. Just not even, you can't even simplify that, so just leave it. So there's our answer after we add 2 to both sides. 2 plus or minus the square root of 15. One more. Let's solve this one by completing the square. Not going to be pretty. I would use quadratic formula every time to solve this. But let's add 2 to both sides. Let's divide both sides by 3 to get the lead coefficient to be 1. Half of 2 is 1, and 1 squared is 1, so that's why I'm adding 1 to both sides. Adding 1 to both sides. 3/3 is 1. That's a perfect square. Take the square root of both sides. You get plus or minus the square root of 5/3. Oh, we got to simplify that too. And then subtract 1 from both sides. Negative 1 plus or minus the square root of 15 over 3. I'll tell you where I got the square root of 15 over 3. You can't have a fraction in a radical. So I'll rationalize the denominator. Square root of 5 times the square root of 3 is the square root of 15. Square root of 3 times the square root of 3 is 3. Okay, that's a doozy of a lesson. Completing the square has its place. That place is when the lead coefficient 1 and the b term is even. That's when I'd use it. All right. Good luck.